What's up, everybody? Here are the solutions for quiz 11, and for the first problem basically we are going to be using Newton's method to approximate the roots of the equation x squared minus 2 equals 0. And just to remind you, the formula for Newton's method is, if I want to get the next term in the sequence, I take x sub n and I subtract f of x sub n over f prime of x sub n. So for our function x squared minus 2, what that becomes is x squared minus 2 divided by 2x. Now with the initial value x1 equal 1, to get x2, that means I have to take 1 minus 1 squared minus 2 divided by 2, and if you do the computation, this turns out to be 3/2. So that would be the approximation x sub 2, 3/2. And to get the next one, x sub 3, I take my 3/2 and I plug it into the formula here, and that gives me 3/2 minus 3/2 squared minus 2 divided by 3 this time, because I have 2x, so 2 times 3/2 will be just 3. And once you do the computation, this turns out to be 17 over 12. So these would be x sub 2 and x sub 3. For problem 2, what we have is a function x squared minus 1, which factors as x plus 1, x minus 1. So we have two roots for that function. And the question is to compute the 2016 term in the Newton's method. Right? So let's see what happens. Right? If I start with x sub 1 equals 1, which is one of the roots, for this function the formula is going to be x sub n plus 1 is x sub n minus x sub n squared minus 1 divided by 2x sub n. So when I plug in 1 into that formula, notice that the numerator of this is going to be equal to 0. So I get that x2 is just 1 minus 0, so just 1. Similarly, when I take x3, I plug in my x2, which is 1. I get a 0 for this term of the Newton's method formula. So again, I get 1. And basically, the pattern is that no matter what I plug in right into this equation, if I start with one of the roots, no matter how many terms I get, I'm going to remain, I'm gonna keep getting the same value back. So that means x 2016 should be equal to 1. Alright, let's look on the other side of the quiz. So now we have a rational function, and we want to figure out what the slant asymptote is. Notice that the degree of the top is 3, the degree of the bottom is going to have
a slant asymptote. So let's see. To figure out what the asymptote is, and I'll go ahead and do that. So I have 2x cubed plus 4, and I have to divide that by x squared minus x plus 1. So that means my first term is going to be 2x. I'm going to multiply. I get 2x squared minus 2x cubed minus 2x squared plus 2x, and now I subtract that term. So the x cubed term disappears, the power drops by 1, so I'm left with 2x squared minus 2x, and I also have to bring down the 4, plus 4.
So now let's divide it again. I get the result 2, positive 2. Multiply, I get minus 2x squared minus 2x plus 2. And when I subtract that, like this, the x squared cancels, the 2x cancels, and I'm left with just a remainder of 2. And now since the degree here is 0, it's smaller than the degree of what I'm dividing by, that means I get to stop. And this right here, that is my slant asymptote. So the correct answer here is E, 2x plus 2. Now the second to last problem on the quiz has us find some antiderivatives, and for the first one, the antiderivative of 2x in its most general form is x squared plus a constant. So that when I take the derivative of this, the derivative of any constant is 0, I end up with 2x. For cosine of x, the antiderivative is going to be sine of x, again plus a constant, so that's the most general. And for 3x, 3 to the x ln 3, well, I know that the derivative of 3 to the x is 3 to the x times the factor of ln 3, so that means the antiderivative is 3 to the x, but I also need to add the constant. Now for part D, 1 over cosine squared, notice, is just secant squared. So the antiderivative of that is going to be tangent x plus c. For x to the fourth, I know my degree has to go up by 1, but I have to divide by my new exponent. So when I take the derivative, 5 comes down, canceling my denominator, and I'm left with just x to the fourth, and I add a constant. Now for the last
problem, I have something that resembles the derivative of what's inside a square root.
So that means this 2x piece had to have come from chain rule. And now that means I just have to look at a function of the form x to the 1/2, right? The square root function, and take the antiderivative of that. Well, what I do is I add 1 to the exponent, so I end up with the parenthesis to the 3/2, and I have to divide by 3/2, so that's the same as multiplying by 2/3. Inside I'm going to have x squared plus 8 plus c. So let's check quickly. Let's take the derivative of this, see what we end up with. 3/2 comes down, canceling the 2/3. I subtract 1 from the exponent, I'm left with the exponent to half, or square root, of x squared plus 8. But by chain rule I need to multiply by 2x, and that's exactly this front term over here. So indeed, it does check out. Now for the last problem, the question is, which of the following functions has a slant asymptote? And we discussed in the tutorial that slant asymptotes only happen when the degree of the top is exactly 1 larger than the degree of the bottom, and that only happens for answer B over here. Over here the degrees are equal, so we get a horizontal asymptote actually, right? We get a limit at infinity to be positive 3 over 1. Over here the degrees differ by more than 1, so we do not get a slant asymptote, which has the equation of a line. It's a different type of asymptote. And that's it for the quiz.